Okay, finally we get to Chapter P, Section 5, the factoring of polynomials. So, factoring, you should have seen this in a previous math class. It is the process of writing a polynomial as the product of two or more polynomials. Now, keep in mind, it is a product, and a product means multiplication. So when you are factoring, you're going to have back-to-back parentheses. Polynomials that cannot be factored using integer coefficients are said to be prime. And in any factoring problem, always, any factoring problem, the very first thing that you always do is to first look for the GCF, or the greatest common factor. Okay, that's our GCF. It's going to sneak up on us. Just when you think there's no GCF, there is. So just always make sure that you are looking for that GCF. The GCF is an expression of the highest degree that divides each term of the polynomial. Okay, and in fact, when we are factoring, we are reversing the distributive property. We are dividing. Okay, so factor means divide. Factoring is reversing polynomial multiplication. You are dividing out common factors. Okay, and we're going to do some factoring right now. We do go through Chapter P, Section 5 fairly quickly, so there's a lot of factoring. All right, factor out the greatest common factor, the GCF. Now, when you factor out the greatest common factor, you must write your answer as a product of terms. So we look at this and we say, what does each term have in common? Well, I look and I see two terms. Remember, terms are separated by addition and subtraction. And I'm going to look at the numeric part, the integer part, 12 and 8. Well, 12 and 8 have a 4 in common as its greatest common factor. And then I look at my variables, and I'm like, this got x to the power of 4. This is x to the power of 2. At most, I can take 2 x's out of each one. Okay, even though this one has 4, I can only take 2 out. So my greatest common factor is 4x squared. And I put in open parentheses. This is where my product is coming into play. Okay? And you're actually going to divide 12x to the power of 4 by 4x squared and 8x squared by 4x squared. Okay? 12 over 4 is 3, so the 3 goes inside. X to the power of 4 divided by x to the power of 2 is x to the power of 2 if you use properties of exponents. Negative divided by positive is negative. 8 divided by 4 is 2. And the x squared divided by x squared is 1. 2 times 1 is 2. I'm done. Final answer, GCF, is fairly easy. Now, keep in mind, you're going to get this factoring packet. And it does say up here, for all the problems, be sure to factor out any leading negatives. That's customary. So I see a leading negative. In other words, the first term has a negative. You're going to factor out the negative. We'll talk more about that in class. Okay, let's look at the second kind of problem, because this really is a GCF problem. It looks a little stranger. You probably have seen this type of factoring before. And now remember, terms are separated by addition and subtraction. This 3x and this quantity x plus 5 are connected by multiplication. Okay, so 3x times quantity x plus 5 is one term. Subtract 2 times quantity x plus 5 is the second term. What do they each have in common? Well, your answer should be they each have an x plus 5 quantity in common. So we're going to write the x plus 5 on the outside. Now, if I divide the product of these two things here by x plus 5, what's going to be left? A 3x. And if I divide 2 times quantity x plus 5 by x plus 5, what's going to be left? The 2. Remember, this is negative divided by positive, so my answer there is negative. going to move right along now to factor by grouping. Okay, factor by grouping. Some polynomials only have a GCF of 1, but rearranging terms that have a common factor sometimes helps us to factor. So we're going to rearrange. Okay, the directions here tell us to factor by grouping. When you have 4 terms, 4 or more terms, you're going to factor by grouping. Typically, we group the first 2 and the second 2 as long as they have something in common. But we're going to look here and answer this question. Does each term in this polynomial, there are 4 terms, this one separated by subtraction, then this one addition, then this term subtraction, then this term, 4 terms. Do they all at the same time have something in common besides a 1? Nope. There is no GCF of the whole entire polynomial other than 1. So we need to group. Okay, again, take a look. Do the first 2 terms have something in common? Sure they do, x squared. So I'm going to group an x to the power 3, subtract a 3x squared. Always put plus in the middle of your groupings, even if it's minus. I'm going to show you down here at the next example. When there is a subtraction, always put addition between your groups. And I'll tell you why in a few moments. Okay, so I grouped these 2. Now, when you group, you are actually looking for a greatest common factor in each group. The first group has an x squared in common. So we're going to factor out the GCF of the first group, and I end up with x subtract 3. The second group has a positive 4 in common. So plus 4. And when I divide, because remember, I'm taking GCF out, I'm factoring it out, hence I'm dividing it out. 4x subtract 12. 4x divided by 4 is x. 12 divided by 4 is 3. Sign is subtraction. Now, I'm not finished factoring yet. Okay, all I did was group it and take a GCF out of each group. I still have 2 terms. This one here, connected by multiplication, and this one, separated by addition. What do these 2 things have in common? Well, you should recognize that that was just like this problem where they both had a quantity x plus 5 in common. So these have quantity x minus 3 in common. We write it one single time. We are dividing both terms by that quantity x minus 3 once. Okay, so you write it one time. Okay, and when I divide the product of x squared with x minus 3 by x minus 3, what's left? X squared. And when I divide the product of 4 and x minus 3 by x minus 3, what's left? 4, and it's positive. Now I have a product of 2 or more binomials, trinomials, polynomials. I am finished factoring. On to the next problem. It's very much the same. I've got 4 terms. Factor 4 or more, we're going to group. The first 2 do have something in common. Okay? Group. 2 and 2. So I got x to the power of 3 plus 6 times x to the power of 2. Always put plus. Shove the negative inside. Because you're going to be accustomed to factoring out the leading negative. And within that grouping, there is leading negative. We're going to pull that negative back out. It just helps you to remember that you have to divide both of those items in here by a negative. Sometimes students get incorrect signs, is what I'm trying to say. So in the first group, the GCF is x squared. We're going to take the x squared out. We're going to factor it out. Factor means divide. X cubed divided by x squared is x. 6x squared divided by x squared is 6. Here, remember I said shove the negative in so we can pull it back out, that leading negative. And the only thing that divides 2x and 12 is 2. So we're actually dividing out or factoring out a negative 2. And again, factor means divide. Okay, negative 2x divided by negative 2 is positive x. And then, of course, negative 12 divided by negative 2 is positive 6. And I look and I say, ooh, I like this because both of these have a quantity x plus 6 in common. Remember, this is not a product of polynomials here. It's separated by subtraction. So I'm going to factor out a quantity x plus 6 because both of those terms have that in common. And what's left is when I divide this out of each term, I'm left with x squared minus 2. And since x squared and 2 have nothing in common, neither does x and 6 in the first grouping, I'm done. And finally, part C. It is grouping because why? Because there are 4 or more terms. So we're going to group. The first two have something in common. They have an x squared in common. So that's x cubed, subtract x squared. Add, remember, move the negative in. Okay, GCF of the first group is x squared. When I factor it out, I'm left with x, subtract 1. Remember, anything divided by itself is 1. You need the 1 there. Here, I'm going to take out the leading negative, and I'm going to take out a 5. And now negative 5x divided by negative 5 is positive 1x. And positive 5 divided by negative 5 is negative 1. I'm still not finished factoring because, look here, I've got a subtraction between this term and that term. These two terms have a quantity x minus 1 in common. And what's left after I divide it out of each term? Quantity x squared subtract 5. Okay, and that's how you're going to fact polynomials that have 4 or more terms. For now, we're going to learn another method when you need to group a trinomial and a monomial. But for now, factor by grouping typically is group the first two, group the second two. You might want to move them around, rearrange them, if that seems to be a better option. Okay, the next type of factoring is what we call trial and error. Okay, factoring trinomials. Okay, now notice we had 4 or more terms was grouping, and we had GCF. That's all we had so far. Now, when you have trinomials, and this should be a review, you're going to use trial and error. Trial and error is necessary for this type of factoring. Now, if I consider the trinomial, and this is an easy one, x to the power 2 plus 8x plus 15. Your job is to factor that trinomial. You're going to end up with 2 binomials with these. When you divide or when you factor it, you're going to end up with 2 binomials. Okay, and the key is you do have to talk to yourself a little bit. Okay, so you have to ask yourself, what 2 numbers that when I multiply them give me the last term in that trinomial, and if I add or subtract those same 2 numbers, they're going to sum or differ to the coefficient of the middle term. So it is a little bit of dialogue, and sometimes you may have to write things down. Now, I'm going to put on the screen and zoom out for you something that I want you to copy. So, on a separate sheet of notebook paper, okay, we're going to, or I want you to copy this down. Okay, I do not have it on a handout, and so I want you to copy it down because there is merit in writing things out in mathematics. It helps you get it into memory better. Okay, so you can pause the video and copy this online paper. Okay, hopefully you have copied this because I want you to listen as as I'm going over this. All right, so there are 4 variations of ax squared plus bx plus c. right? Could be plus plus, could be minus plus, could be plus minus, or minus minus. Okay, so we're always going to read these backwards. Remember, when you're equation solving, you always reverse the addition by subtraction. You reverse the multiplication by division. Everything is reverse. And so with factoring, since factor means divide, we're going to actually read this backwards. So I'm going to need two values that multiply to C that when I add them, give me a B. And not only that, this plus means that the signs in my binomials right here are the same, and this tells me that they're both plus. Okay, so I know I'm going to get x plus something times x plus something. Okay, this something times something is kind of equal to C. Now, it's a little bit tricky to think about those values when you just have all A's, B's, and C's. We're going to do it with actual numbers. Okay, but I want you to learn the properties of the signs here because this works for all trinomial factoring. When A is 1 and when A is not 1. We'll talk about that in a little bit as well. Okay, again, I'm reading it backwards. This means same signs that I'm going to add. Since they're the same signs, this means they're both minus. Okay, always read it backwards. Multiplies to this. When I add them, gives me the B. Okay, when it's subtraction on the end, that means you're going to subtract your products. And the signs of your binomials are going to be opposites. One's going to be plus, one's going to be minus. Okay? And then again here, when I read this backwards, multiplies to C, subtracts to B. The signs are different. I'm going to subtract to get this value of B. Okay, so now we're going to actually go on to some specific examples in this trial and error type of factoring. Okay, so our first example, and I'll zoom back in again. So I'm back up to this example up here. Notice it is a plus plus when I read it backwards. You always want to read it backwards. Okay, plus plus. So what are the factors of 15 that when I add them, I get 8? Well, factors of 15 meaning what two numbers are going to multiply to give me 15? Well, 1 times 15 is 15, and 3 times 5 is 15, and I believe we're out of factors. Okay, so is it 1 and 15 that add to 8, or is it 3 and 5 that add to 8? You should see that it's 3 and 5. So when we write our answer in factored form, we're going to put x here and x here because x times x is x squared. I know it's 3 and 5 because 3 times 5 is 15 and 5 plus 3 is 8. Signs are the same. They're both plus. So I go plus, plus. Okay, so you know with the trick with the signs, not that it's really a trick, but if you know that property with the signs for factoring, it makes your job a whole lot easier. Okay, if no combinations exist, then we say the polynomial is prime. Okay. Folks, in your homework and any kind of assignments, prime doesn't happen too often. Just keep that in mind. All right, for these specific examples, it says factor the trinomials. Keep in mind your signs. Okay, so I'm reading it backwards, and I'm like, oh, I need two numbers that multiply to 5 that when I subtract, give me a 4. So this minus on the end means you're going to subtract. And not only are you going to subtract, but when you set up your two binomials, the signs in those are going to be different. And when they are different, that's going to tell us the sign of the larger product. And we'll talk about what I mean larger product in a moment. Okay, so what two numbers multiply to 5 that when I subtract give me a 4? Well, 5 is prime. There are only 2. So it's got to be 1 and 5. We know the signs are different. Now, when I say product to get that larger sign, I'm talking about the product of the outers and the inners, okay? X and 5 are on that outmost, okay, farthest left, farthest right, okay? And the 1 and the X are on the inside. That's inners, outers, Okay, so if I was foiling this, that's what I'm talking about, products. X times 5 is 5x. 1 times x is 1x. What's bigger? Well, 5x is bigger. So the 5 has to get the subtraction. And by default, the 1 gets the addition because the signs are different. And you can check it by FOIL. This is x squared. This is subtract 5x, add 1x. When I subtract 5x and add 1x, I do get negative 4x. And positive 1 times negative 5 is negative 5. Okay, let's do the next one. This means same signs. Same signs in your two binomials. And not only are the signs the same, but we're going to add products. Okay, so you always want to think this out first. This tells us that both signs are negative. Okay, so we get x, x. We know it's both negative. Now I need two numbers that multiply to 45 that when I add them give me a 14. Well, you could go through, 1 times 45, 2 doesn't divide it, 3 times 15, 4 doesn't divide it, 5 does, 9 times, and I believe those are the only combinations of factors for 45. All right, so which ones are going to add to 14? Well, right here you go, 9 and 5. And we are finished with that problem. Okay, one more to do. All right, I need two numbers that multiply to 50 that when I subtract them, I get a 5. That's how you should be reading these. Two numbers that multiply to 50 that when I subtract them, it gives me a 5. Not only am I subtracting, but the signs in the binomials are different. Since they're different, this middle sign is the sign of the larger product. I always say larger product because it is the product of the outers and the inners. I never say larger number because when we factor when a is bigger than 1, it's not always the larger number in this first or second binomial. Okay, it's always the larger product. All right, two numbers that multiply to 50. We got 1 and 50. We got 2 and 25. We got 5 and 10. I think that's it. Okay, we know it's x here and x here. We know the signs are different. Well, I got to figure out my factors first. 2 that multiply to 50 that subtract to 5. That's 5 and 10. Since this is the sign of the larger product of the outers and the inners, 10x is bigger than 5x, so 10 gets the plus, 5 gets the minus, and we're done. Okay, one more page, and we're going to go on to factoring trinomials, where a is not 1. It's bigger than 1. So notice the examples that we just factored all had 1 as leading coefficient. What happens when the leading coefficient of the trinomial is more than 1? You're still going to use trial and error. It's still trial and error. Kind of like guess and check, but I call it trial and error. The leading coefficient is 2. Now I need to also consider factors of the first term. All rules with the signs are still the same. When I read this backwards, I need products that are going to subtract to a 5. My signs in my binomials are different. This plus is the sign of the larger product. Okay? But now I have to consider the factors of the leading coefficient as well. You must strategically place the factors of the first and the last terms and then test the combinations. Okay, you got to test the combinations. All right, I like to, since this 2 is on the left side of the polynomial and the 3 is on the right side of the polynomial, I like to write my factors of the left on the left and and my factors on the right. I do write this, especially when the numbers get bigger. You know, 2 and 3 are prime, so this one's not going to be that much of a beast to figure out. Okay, I like to put this on the left because in my binomials, this is my x side, right? This is going to be 2x and 1x. And I have to figure out where to put the 3 and where to put the 1. Okay, now remember my goal is to get products that are going to subtract to 5. I have to use a 3 and a 1 because it's prime. If I put a 3 here and a 1 here and I check it, 2 times 3 is 6. That's the outer product. The inner product is 1. 6, take 1 away, is 5. Since 6 is the larger product, 6 has to be positive, right? Because that's plus there. And then this one by default gets the subtraction. Okay, let's try the next one. Signs are the same. They're both going to be subtraction. But now I've got a 6. 6 is not prime, so there's a couple more factors for that. So again, on the left, I like to say, well, how do I get 6? 1 times 6 or 2 times 3? How do I get 12? 1 times 12, 2 times 6, 3 times 4. Once I get back to back or close here, I'm done with figuring out what my factors are. All right, so I know I'm going to do 2 binomials. I know the signs are the same. They're both minus. I'll do that later. But now I have to play the game with trial and error. My goal is to get a 17 in the middle. That's my goal, 17. And I also know that I'm going to add to 17. My products are going to add to 17. All right. Now, usually, this is like one of those things you can follow. 17 and 12, they're pretty close together. So usually when this happens, 6 is not that far away from 12. Usually when these are all around the same range, it's usually the numbers on the number line that are closer together, usually. I always like to check them first. Now, if this number in the middle is way much bigger than those other numbers, then I tend to pick the ones that are farther apart. You know, like 1 and 6 are farther apart than what 2 and 3 are. 1 and 12 are farther apart than what 3 and 4 are. So usually when this number is pretty close to those, I go with those. The ones that are closer together on the number line. So now I'm going to test it. If I do 2 times 3, I get 6. Remember, I'm adding to 17. And I do 3 times 4, okay, 3 times 4, I get 12. Well, 6 and 12 is not 17. But what if I were to switch and say, instead, let's multiply 2 with 4. That gives me 8. And 3 multiplied with 3 is 9. Oh, look at that. 8 plus 9 is 17. So there I have figured out what my factors are. Now remember, this side is your x side. So this is 2x and 3x. And we said that the 2 and the 4 have to get multiplied together. Folks, they're not going to get multiplied together if you put the 4 in here. Remember, you're reversing the FOIL. So the 4 has to go here and the 3 here. Check it. That's 8 of them and 9, right? When I multiply, 8x, 9x adds to 17. Signs are the same. They're both minus. Okay? Trial and error. It's going to take you a little bit of time. Okay, and the last one. We got 8 here, so I got 1 times 8 or 2 times 4. And 4, that one's not so bad. 1 times 4 or 2 times 2. You see how this 33 is much bigger than the 8 and the 4? So I'm thinking it's going to be some factors that are farther apart. You know, 1 and 8 are farther apart than what 2 and 4 are. And 1 and 4 are farther apart than what 2 and 2 are. So let's check and see if this is the case. Remember, my goal here is to get to 33, right? That's the coefficient of the middle term. And I'm going to add. Okay, well, I see it right away. 8 times 4 is 32. 1 times 1 is 1. 32 and 1 is 33. So I'm going to use the 1x and the 8x. And remember, we had to have the 8 being multiplied by the 4. So the 1 goes over here. See? The 1 and the 4 are on the right side. The 1 and the 4 are on the right side of the binomials. Signs are the same. They're both plus. Okay, and there ends our factoring lesson for now. Have a great day.